Right now, the moon is above you somewhere. Even if you cannot see it, it is there. It pulls at the oceans. It stabilizes the tilt of Earth. It quietly shapes the rhythm of life. It feels permanent, ancient, untouchable. But imagine this. Tonight you step outside and look up. The sky is clear. The stars are sharp. The air is still. And the moon is gone. Not hidden behind clouds. Not in eclipse. Not dimmed. Gone. At first you would think you were mistaken. Maybe it has not risen yet. Maybe you are facing the wrong direction. But within minutes, photos from every continent confirm the same impossible truth. The moon has vanished. And in that first hour, nothing dramatic happens. The oceans do not explode. The ground does not crack. The sky does not burn. Life continues. But something invisible has already changed. The moon is not just a bright object in the sky. It exerts gravitational pull on Earth. Every second, it tugs at the oceans, creating tides. That pull is gentle but massive. Entire bodies of water shift because of it. Without warning, that pull disappears. At first, the oceans continue moving from momentum. Tides do not instantly flatten. Water already in motion keeps moving. But the system is no longer being driven by lunar gravity. The balance is broken. Within hours, coastal regions begin noticing strange tidal behavior. Some tides appear weaker. Others arrive earlier than expected. The predictable rhythm that fishermen and sailors have relied on for centuries begins to distort. And that is only the beginning. The moon does something even more important than controlling tides. It stabilizes Earth's axial tilt. Right now, Earth is tilted about 23.5 degrees. That tilt gives us seasons: summer, winter, spring, autumn. The moon acts like a gravitational anchor, preventing that tilt from wobbling chaotically. Remove the moon and Earth becomes less stable. Not immediately, not violently, but gradually. Over months and years, Earth's axis would begin to drift more dramatically. Instead of a steady 23.5 degrees, the tilt could fluctuate unpredictably. Some years, winters could become brutally long. Other years, summers could become extreme beyond anything recorded in history. But on that first night, as people stare at the empty sky, something else begins to feel wrong. Darkness. The moon reflects sunlight. On a full moon night, it illuminates landscapes. It shapes nocturnal ecosystems. Many animals depend on moonlight for navigation, hunting, and migration. Suddenly, nights become far darker than humanity is used to. Predators struggle. Sea turtles lose orientation. Coral spawning cycles become confused. Subtle biological clocks fall out of sync. Humans too feel it. There is something unsettling about a sky missing its brightest companion. The moon has been part of human history for as long as we have looked up. It inspired calendars, myths, religion, poetry, and exploration. It guided sailors across open oceans. And now it is gone. In observatories across the world, scientists scramble for data. There was no explosion, no debris field, no incoming warning. It did not drift away slowly. It simply ceased to exist. And that detail is terrifying. Because the moon does not just orbit Earth randomly. It is locked in a gravitational dance. For it to vanish completely defies everything we understand about physics. But while scientists search for answers, something larger begins unfolding in silence. Earth and the moon orbit a shared center of mass. Remove one partner from that dance and Earth's motion shifts slightly. It is subtle, almost undetectable at first. But orbital calculations begin showing tiny deviations. And those tiny deviations hint at a future far more unstable than anyone expected. That first night, people cannot sleep. The sky feels wrong. The world feels incomplete. And humanity begins to understand something it never questioned before. The moon was never decoration. It was infrastructure. And without it, the planet is no longer the same. And the consequences do not wait long. Within the first 24 hours, the oceans begin adjusting to their new reality. At first, the change is subtle. Tides still rise and fall because the sun also pulls on Earth's water, but without the moon's gravitational influence, the tidal system loses nearly 2/3 of its strength. Coastal regions that depend on predictable tidal cycles begin noticing irregular timing and reduced height. Harbors designed around specific tidal ranges experience unexpected shifts. Fishing industries are disrupted almost immediately. But the real instability is not just in the water. It is in the planet itself. Earth and the moon were locked in a gravitational partnership. The moon did not simply orbit Earth. It stabilized it. Our planet spins on its axis once every 24 hours, and that axis remains relatively steady because the moon acts as a gravitational anchor. Remove that anchor and Earth becomes more vulnerable to wobbling. Not instantly catastrophic, but progressively unstable. Over months and years, computer simulations predict that Earth's axial tilt could begin fluctuating far more dramatically than it does today. Instead of a stable 23.5-degree tilt, the planet might swing unpredictably between far steeper and far shallower angles. That means seasons would no longer behave normally. Some years, winters could become brutally long in certain regions. Other years, summers could become relentless and extreme. Parts of the planet might tilt toward the sun for extended periods, overheating ecosystems beyond recovery. Other regions could remain angled away, plunging into prolonged freezing darkness. Agriculture, already dependent on delicate seasonal balance, would begin to fail under these unstable climate patterns. Global food systems would strain. Migration routes of animals would collapse. Forests adapted to specific sunlight cycles would begin dying in waves. Meanwhile, the oceans continue evolving in ways that are less visible but equally dangerous. Tides play a critical role in mixing nutrients and oxygen in coastal waters. Without strong lunar tides, vertical circulation weakens. Estuaries and coral reefs begin experiencing stagnation. Certain marine species that rely on tidal movement for feeding and reproduction start declining. The ripple effects move through food chains from plankton to large predators. But something even slower and more profound is happening. The moon currently exerts a braking effect on Earth's rotation over extremely long timescales. Remove it, and that long-term stabilization mechanism disappears. While the immediate change in day length is small, the planet's rotational dynamics begin shifting over geological time. Combined with axial instability, Earth's climate becomes less predictable than it has been for millions of years. Scientists run projections and reach uncomfortable conclusions. Without the moon's stabilizing presence, Earth could experience chaotic tilt variations similar to what scientists believe happened on Mars. On Mars, extreme axial shifts contributed to severe climate instability. Earth was protected from that fate by its large satellite. Now that protection is gone. In the weeks following the disappearance, observatories across the world scan the region where the moon once orbited. There is no debris field, no gravitational disturbance pattern, no drifting fragments, just empty space where a celestial body once existed. That absence becomes more disturbing than destruction, because destruction follows rules. Disappearance does not. As months pass, subtle climate irregularities begin emerging. Certain ocean currents shift slightly due to altered gravitational interactions. Storm patterns show minor but measurable deviations. These are not apocalyptic events, but they are warnings. Earth is adjusting to a new equilibrium, and equilibrium is rarely gentle. Humanity begins realizing something uncomfortable. The moon was not just a companion in the sky. It was a stabilizer that quietly protected the long-term habitability of this planet. Without it, Earth does not die instantly, but it becomes less certain, less predictable, less forgiving. And that uncertainty builds slowly like pressure beneath the surface. The chaos has not exploded yet, but it is forming. And the longer the planet spins alone, the more that instability grows. And that instability does not remain theoretical. Over decades, Earth begins revealing what it looks like without its gravitational partner. The axial tilt continues drifting within wider margins than before, and even small changes in tilt translate into massive climate shifts. Regions that once experienced moderate seasons begin swinging between extremes. Agricultural zones migrate toward new latitudes. Some nations face prolonged droughts while others endure relentless flooding. Weather patterns grow less predictable, and long-term climate forecasting becomes increasingly uncertain. Humanity adapts because humanity always adapts, but adaptation comes at a cost. Infrastructure must be rebuilt. Food systems must be redesigned. Entire economies must shift to survive a planet that no longer behaves the way it once did. Meanwhile, the oceans settle into a weaker tidal rhythm dominated only by solar gravity. The dramatic rise and fall that once defined coastlines becomes muted. Some coastal ecosystems slowly decline as nutrient cycling weakens. Fisheries shrink in certain regions. Biodiversity patterns shift. None of it is instantaneous extinction, but it is gradual erosion of balance. And balance is what allowed civilization to flourish in the first place. Over centuries, the absence of lunar stabilization compounds the problem. Computer models suggest that Earth's tilt could oscillate far beyond its current stable range, potentially reaching angles that trigger severe glacial expansion or intense planetary heating. Entire ice sheets could grow or melt unpredictably depending on how sunlight distributes across hemispheres. The long calm period of climate stability that enabled cities, agriculture, and global trade may have been a rare gift of lunar alignment. There is also a deeper psychological impact that no simulation can measure. For as long as humans have existed, the moon has been a constant presence.